Hello everyone, welcome back. So in this video, we are going to understand the Leetcode problem number 2573. It's saying that find the string with LCP. So we'll try to understand detail this question. This is a very hard problem, but I'll make it very simple. So keep watching. If you have any doubt, you can ask me in the comment box, and you can join my YouTube channel, and you can consistently walk through on daily basis to understand how we can solve the approach, right? How to solve the problem with a different approach, and we'll try to understand from there. Okay, so let's go through this question and we'll try to understand. If you are new at ExpertFunda, I'll suggest please subscribe this channel so you can prepare on the daily basis of the daily question series as well as other questions that we used to put. So let's try to understand here that question is 2573. It is saying that find the string with LCP. So LCP is a longest common prefix, means we define the LCP matrix of 0 index, that is called word, of n lowercase English letter, and it is as a n cross n matrix. So as you can see here, this is the LCP matrix we have given. So it is saying that LCP at I and j is nothing but is equal to the length of the longest common prefix, means the length that we have given at each index. Either we are talking about this, let me tell you, either we are talking about this 4, right, or any of these elements, right? So this is nothing but the length of the longest common prefix between where, so the word that we have given, right? So let's suppose the word we have given at I to n-1 and word j n-1, means these two difference. Let's suppose the word is at here and the word is at here. So if this is I, this will be j, right? So if you want to take the size of the word, let's suppose I is the index, there is some value is there, right? So from here to here, it's called the length. So this length we have given as a LCP elements, as you can see here at each places we have given. Now the question saying that we have given this matrix LCP, we have to return the alphabetically smallest string word that correspond to the LCP. If there is no such string, we have to return in the empty string. Okay, so you can go through this one, what is lexicographically, right? We try to understand what the question is saying. That let me tell you what we have, right? So very first, that you should understand what the problem is asking. Okay, if you understand 40% work is already done, you don't need to go through in deep, right? So very first, you are given a matrix called LCP, okay, where LCP at I and j represents the longest common prefix length, which is between the starting suffix starting at the index I and suffix starting at index j, means the two indexes that we have given from there, right? In some mystery string that is called words we can take. So let's suppose what is our job, what is our goal? We have to reconstruct that a string s using only the first k lowercase letters where k is also given, right? Otherwise we'll return empty string if no valid string exists. So the string must be of length n using a, right, alphabetical character a through the kth letter, and means we will start from a and we'll keep going till the kth letter, right? The LCP matrix you compute from it must exactly given 1, right? So pause this, try to understand what I'm trying to say here, right? Let me go ahead. So let's assume that we have given this LCP, and if I'll represent this one, it look like this grid, right? So each index we have given, also we have given k equal to 3 we have given. Okay, so we'll try to understand how to what the question exactly it is saying that. Okay, so can I say that if I'll represent this grid, so I is look like this and j is look like this, right? So the grid saying that if I and j, the row column and the columns are there, right? So j is the column, I is the row columns. Okay, sorry, I is the columns and j is the row columns. So if I'll say that this is LCP matrix, it means this yellow color represents the self match. So if you see here, I'm talking about these yellow color marks, right? These are nothing but what is a self match. This red color that you are seeing at each places, right? These are nothing but is a separate one, that is the 0 characters or different cats, we can say that. And other characters other than this is a shared prefix like 2, 1, 1, 2 4 in the purple shaded, right? So if we'll represent this, the answer should be like this, right? A B A C. How we will understand further, but the answer is like this: A B A C. How? Let's try to understand how. Now think that we have seen that LCP 004 means the string has 4 length, right? If you come here, the very first element that we have here is 00. I'm talking about this one. Okay guys, so it is 4. It means what? It means that it has a string has length 4. Now if you take LCP 02 means 2, means if you take the string from S0 to N, N is nothing but 1 right here, because LCP is 0 and 2, so it should be go to 0 to 1. Similarly, for another string that start at 2, it will go to 3 and so on. So this is called shared 2 character prefix. Okay, and that is why if you see it is coming, all the shared is coming 2 here, means in this row I'm talking about. Okay, when at 0. Similarly, if both character will say that S at 0 and S at 2 both having A. Why? If you see here, so this it is saying that this character is also giving the same value as you can see here, right? So S at 0 is equal to S at this, both having A character. So LCP 001 means if both are not equal, right? This is what exactly we have represented here in this section, right? Okay, so you can go through this, right, and you can understand. So pause this and try to understand. Okay, next we have, let's suppose how we are going to construct the greedy construction. How we'll do the greedy constructions to understand how we will start. Let's suppose that very first index start at 0 and it is unassigned, right? So we greedily pick the smallest available letter called A and we'll build this, right? Because initially if we pick this index, right, there is nothing is there, right? So we are trying to build the string S, right? But if we'll pick, we know that we have 4 digit, right? So we'll take the 4 digit characters, because LCP 00 is nothing but the 4 as a what you call length. So the string length should be 4. Okay, so we will try at index 0. So let's suppose that when we go to the index 0, right, means we are talking about this one. So what will happen? So if you have seen that initially it was 0, right, but now we have converted into what? A. We have put the A because we have assigned all the value that will get assigned. It will start from A, right, and it will go till K, right? So what we will do now, we can scan this LCP. We'll say okay, LCP 02 is nothing but 2, right? So we'll say, is it greater than 0? Yes, it is greater than, meaning we have to suffix at 2, shared a prefix with suffix at 0. So what we will do, we'll put A. S at 2 is nothing but A, right? So we'll start A and this will also get started with A, because both are same, right? Both are shared, we can say that. So we have put there. Now what we will do, we'll assign S at, we have already assigned A. S at 0 is A. For all j, if LCP ij is greater than 0, then S at j is S at this one, right? Both are A, so we have assigned A. Next, we'll move the pointer and we'll come to I equal to 1. So it's still unassigned because we have not done anything, right? So we greedily pick this next character B, because after A, what comes? B comes, right? So we'll say LCP 1 0, we'll put, let's suppose it is 0. So we have confirmed already, right, that S at 1 and S at 0, right, is not same, right? So we'll keep the different value. So what we will do, we'll pick another letter B and we'll keep here at this position. Okay, let me show you. So what we have done, let's suppose we have put the letter B. Now next character, next cell is left is this one. So we have already assigned A here in the cell, right? So we have moved directly to index here, and this index I equal to 3 is unassigned since we have not put any value here till now, right? So s at 3 should be, because the last character was what is a, so it should go what, it should go, because we have also added b, right? So we will see the expected answer should be what, a we have already confirmed, b already confirmed. So this was different thing that we have assigned because both are same, right? But a we have already assigned, b already, what is the next character will come? So obviously the character c will come, right? So we'll see this type of propagation. So what it is saying that index 2 is already a, right, that we are talking about this one. So we'll move index 3 here, right, which is unassigned one. Since this LCP 1 3 is greater than 0, so what we will do, s at 3 must be equal to b, right? So we'll say okay, but what we need to do, it is, but wait, the expected answer has c, right? So let's verify that 0 3 equal to 0. If it is confirms, right, it means it should not be equal to. Since if it is not equal to this s at 3 and s at 0, since no propagation will happen, right? So we need to pick a different character, and that is why we'll pick different character. So let's suppose we have built and we have picked another character. Now the string is fully created, a b a c, right? Now if you recompute the LCP table from this string and will compare with the given matrix, they match and they will return string. So if not, it will return empty one. So this is the string we have, and now you can verify vs the LCP. Okay, so what is the intuition we have? Intuition is that we will build the candidate string, right? And we want a greedy character assignment, right? And the verification that we are doing good or not. So let's try to understand the full picture. Very first, in the first phase, what we will do, we'll build the candidate string. We'll scan from the left to right, and if the position I is unassigned, we'll give it the same character as the we will start from the smallest available character, like we have started with the a, then b, then c. So when we thought that we will put what character on the next character, so we'll check that what is the available character. So we have already used a and b, right? So we'll use the next character is c, because this is the smallest available character. Then we'll check, okay, j is greater than I. If it is greater than that, then we'll say LCP ij is greater than 0. It means the suffix at j starts with the same character at the suffix at I. So we'll propagate I s at j is equal to I. If the position is already assigned, so we'll say LCP says that it should match. Otherwise, no. We'll immediately return empty. What we will do, that very first phase, what we need to do, we will build the candidate string. Okay, try to do a scan from left to right. What do you need to do? Very first, you will check the position that you are getting, right? I, right? Index will start from 0 and so on, right? So check each position I is assigned or not. Then give it the next smallest character. If we'll start from, let's suppose 0 index start with A, next character will go with B, and so on C. Then for every character j, what you need to do, check if it is greater than I, right? So you need to check the LCP. If LCP I is greater than 0, it means the suffix at j starts with the same character as the suffix at I. This is the important thing that you should understand. Whole logic is here. Okay, so try to think that what we are doing here means, if LCP at I is greater than 0, it means suffix at j starts with the same character as the suffix at I. So the propagation always happen that s at j means the next character, what the data will be there. Is it the same character that s at I happens, right? So you will add it here. S at this is, let me clean here so you will understand. Okay guys, let me explain it to you again so you will understand clearly. Okay, so what we are saying, that for every j is greater than 0, right? We know I already assigned. So when the next character will come, that is called j, right? So what you need to do, very first you check the LCP at ij. If it is greater than 0, it means whatever the character you have put at I, it should go to a character j, because the same character we have to use as a suffix at I, right? So you will do the propagation s at I equal to s at j is equal to s at I. So if this position is already assigned, the LCP says that it should match, but it doesn't. So immediately return empty. What is the next phase you will do? Next phase, now you have to verify. Means recompute the LCP table from your constructed string and check it cell by cell against the given matrix. So these cases where the greedy assignment was consistent but still wrong in the subtle way. So why verify? Because the greedy assignment handles the character equality at each position, but the LCP value encode a very specific reconstruction structure. So LCP must equal to 1 plus LCP I plus 1 LCP j when S at I is equal to S at j. So your greedy pass doesn't enforces this globally. So verification is a safety net. Okay, I hope you will understand. If not, keep it, pause this video, try to read it so you'll understand the full picture. It's very important to understand. Okay, I'll go ahead. So let's think that what is the first phase we are talking about. The very first phase is that the greedy build. Means for each time what we will do, greedily we will build for each string that start from I, it will go to the left, right? Always start from the left, go to the right. I'm talking about, right? So what you need to do, if you just check that S at I is unset, means unassigned, then assign A, B, or whatever the smallest character is available, right? If you have used A, B, then you will definitely go with the C. C is also used, you will go with the D. Like that you have to check. Then for J is greater than I, you just need to check LCP at I is it greater than 0. If it is, just assign S at J is equal to S at I. This is the logic. Otherwise, any conflict is there, return empty string. Don't do anything. Okay. So in this way, you will get O of n square, because this is a matrix, guys. So obviously you will get O of n square. But we are also building the string. We are keeping the value. So you will need a space at least O of n. Okay. Now think about the candidates. How we'll do the verification, right? So as we know, we have to recompute the LCP from S using the O of n square suffix scan, and if the computed one and the given one is equal to the given one, right? So we'll return S, otherwise return empty. If the match is found, return S. If not, return this. So this is what we have to do, guys. Okay, let's continue. The very first thing is talking about the code. If you're not understanding, let me know in the comment section. The very first you have given is LCP. So very first you need a character to build, right? A string to build. So character string is nothing but a string, right? If you want to build a string, you need a character, because you have to one by one, you have to set it, right? So better to use character string. Okay. Now the grid, how will you do the greedy assignment, right? So very first phase, I'm talking about the first phase. We'll go with the next phase also. See, there is another phase. So well, very first we'll talk about the next phase. The first phase is the greedy assignment. So as you know that we'll go for each character, we need a variable that is called the next character. We'll scan from left to right and we'll keep checking if S at I is 0, right? So we'll say if the next character is greater than 26, return empty one, because we ran out of the letters. Otherwise S at I, you will get converted the next character like this, right? You just need to do A plus the next character plus plus. So S at I, you will get a next character element. Okay. Whenever S at I is 0, it means you have to find the next character. Okay. Then you will do the propagation. Any j where LCP ij is greater than 0 must start with the same character, because both characters are same. This is the logic we have seen, right? So j will start from the next character I plus 1, right? If index I is completed, index j will start from here. So for propagation any j will start from I plus 1, will go to the n. You need to just check if it is greater than 0, right? The very first character you need to check is if S at j is empty, is equal to 0. Then you will fill with S at j is equal to S at I, that we have talked about. This is the main logic we have. Then we'll say, okay, else if it is not equal, return empty. Don't do anything, just return empty. That it is a conflict. Else you need to do what? If it is equal to 0, means both are not same, so we will return empty. Okay. Now coming to the LCP steps, right? How we'll do the verification, right? Recomputation in the LCP. So let's suppose that you take a computed one, and for I and j, you will come with the reverse, right? I in the reverse order. I is n minus 1, j is also n minus 1, right? So you need to check the value only, right? S at I should be equal to S at j. Then how will you do the computation? You will check the computation. You will store the computation like this. So we'll say, okay, I plus 1 less than n, I plus 1 less than n, j plus 1 less than n, right? If these conditions satisfy, it means you have to compute I plus 1, j plus 1 plus 1. So you will do plus 1, otherwise you will start adding here, right? Otherwise you will recompute, else you will recompute and you will store is equal to 0. If it is not computable, you will return empty one. Like this you will check the value, right? And you will assign the value of the computed one, and finally will return, if everything goes well, you will return the new string s. Okay, so this is what we have. So basically the LCP recomputation will fill the table from the bottom right upward corner using the recurrence. So LCP ij is nothing but, if we'll check s at I is equal to s at j, we'll just do 1 plus LCP I plus 1 j plus 1, otherwise we'll put 0. So this is a classical of n square LCP table construction. Okay, so that's all I have in this video, guys. In case you have learned anything, please must like and subscribe this channel. Keep supporting ExpertFunda. If you have any suggestion, right, please do share with me and I will work on that. And in case if you want to learn structured way of DSA preparation, you can join my online classes. So please do WhatsApp on my WhatsApp given number, and you can connect and you can start preparation for the DSA preparation for the product-based company, FANG companies, as well as if you want to do the full DSA course, you can also join my classes. Thank you so much. Let's connect with WhatsApp, and please keep subscribing this channel, like this video, share with your friends, and indirectly or directly support ExpertFunda. Thank you so much.